Well, we got a pretty serious situation here as far as severe weather goes today, right? And you can see why, right? We switch this over to the categorical outlook for today, right? This is updated about 9 a.m. Eastern or so. Pretty much holding on to the same probabilities, but this is your overall thunderstorm risk and slight severe risk going all the way from northern Oklahoma here, all right, all the way up to South Dakota, parts of Colorado, Nebraska here, with a larger marginal risk all the way down into Texas, Arkansas, Montana, Wyoming. So quite an expensive area today, right? Now, if we switch it over to tornado risk, we now have a 5% hatched and a 2% hatched here. What that means is anywhere in this area, the potential for EF2 or stronger tornadoes are possible. So 5% is quite low, all right? But also we have it within this 2% risk. So if we can get some discrete storms to form here, the best chance to have them form is in this 5% area. But keep in mind, 5% is within 25 miles of a given location. So there's a 95% chance you won't see one. Okay, so don't say Tim said there's going to be a tornado going over my house. This is just the general probabilities, right? So anywhere outside of this, you have this 2% risk, you still could get a tornado, but they would likely be less than EF2 strength. All right. So that's what that means. The hail risk here, excuse me, is quite large, right? And this is part of why we have the slight risk here. 15% chance in the hatched area of seeing hurricane force wind gusts. Okay. Parts of central Kansas. All right. Salina, Wichita, parts of northern Oklahoma, northeastern Colorado, parts of Nebraska as well, are all within this area of concern, right? Anywhere outside of that, you have 50% chance of winds exceeding about 60 miles per hour, right? Then within the 5% area, you still could get 60 mile per hour wind gusts, okay? Quite a wide area here, going away from Montana all the way down to southern Texas through Abilene, back to Fort Smith, Arkansas, Kansas City is all in there. So quite an expensive area here. I just realized I was talking about hail. Okay, so that's my bad. 2-inch hail in diameter in the hatch risk, 50% chance. Okay. Anywhere outside of that, you have the 1-inch risk of hail of exceeding 1 inch in diameter and the percentage chance there. Getting it mixed up. Sorry, guys. Anyway, the wind risk was even larger here. 15% chance of winds exceeding hurricane force. Okay. In this yellow area, yellow hatched. And in the 5% risk hatched area, you have the potential for that hurricane force wind gust, but less coverage. Okay. Outside of that, 15% chance of 16 mile per hour wind gusts and the 5% chance covering this whole other area. So quite an expensive area for severe weather today. This has really ramped up since yesterday. And now I'm going to go into discussion about all the different parameter spaces here, future radar, things like that, discussing the possibilities next. So as a reminder, just going to go over, have these different parameters. Here's your overall severe risk. Here's your tornado risk. Here's your wind risk. Here's your hail risk. So now we're going to go over the parameter spaces associated with this and timing, things like that, and evaluate the whole situation here. All right. So to review our mid-level flow, this is the HRRR model, which is a good short-range model I like to use. You got your mid-level feature we talked about here. We got a strong not a strong subtropical jet, but we got some tropical jet down here. And the base of the trough is down here, like right now, right? And you have maybe another short wave that's moving through that's enhancing convection here, right? So now this trough is going to swing through. It's going to stay basically just rotate around, right? This is APM. see it almost takes on a negative tilt here. Now, let's zoom out a little bit. The only way to really get a good look at this is to go to the GFS. So this is a good look, right? General westerly, southwesterly flow here. And on this side of it, you have a northerly flow, okay? And maybe some diffluence in this area, although not strong, but the wind's spreading apart in this area, okay? So that helps to create a void in the mid-levels and upper levels, which the atmosphere likes to be in balance. So air's evacuated up above. You get low pressure at the surface develop and tries to replace it, get some lift, things like that. So maybe this trough is moving through right about here. Okay. Maybe there's some enhancement. Just perturbations moving through the flow. All right. Maybe a little more, another reflection of it down here. But the feature that's really going to help drive the severe weather today is at the surface, right? So you have like a surface low here. Okay. This is at 4 or 5 p.m. You see surface low developing here, right into parts of Kansas. Looks like me. I'm not sure exactly what that is right there. Another vorticity maximum in that area. Maybe convectivity enhanced. A secondary low pressure maybe. But that is going to really help with the severe weather threat. Winds turning with height. But when you have a low pressure in this area, you get winds going this way. You see the winds going this way here. Winds going this way, right? So where you have that turning is important, right? Turning with height. So that surface low being the proximity there is definitely going to help, right? So in the overnight hours, see, it's kind of this nebulous thing, right? And it's not really that focused, but I think it's focused enough. It's really kind of an interesting feature right here. I'm going to see how that ends up playing out. It's almost like a pressure tone right here. Very weird feature there. Anyway, I want to explain that so as much as I possibly can here. So one of the things we look at too is dew points, right? Moisture. All right. When you have 60, 70 degree dew points, which we do, plenty of moisture in the atmosphere to dry severe weather. And if you notice back over here, dew points, 50s, 30s. So anywhere where you have the dew points like that, at least in this scenario, and you have your dry line here, right? So you have your dry line pushing this way, bulges in the dry line, and that may be what we're seeing here as well, right? Denver, 34 dew points, so quite dry. So that being said, any 60 to 70 degree dew points is plenty of fuel in the atmosphere for severe weather. All right, so now as far as severe parameters, let's look at that real quick, if I can get to it here. One thing we look at too is mixed layer cape. Now I'm going to switch back to the HRRR. Mixed layer cape is the total cape, which is the fuel in the atmosphere. We talked about that with dew points, right? That helps with convection, right? You can have all the shear you want, but if you have no cape and no instability, you're not going to get storms, okay? So this is 3 p.m., right? So you can make out where the most instability is here. And that's likely where you're going to have your biggest severe weather threat, right? Okay. Surface low, dry line set up here. A lot of instability in this area. Okay. And some intermittent instability down here in Oklahoma. All right. Even down the southern mode. Okay. And parts of Louisiana, as well. But this is our focus, anywhere in this area, right? And maybe even up into this area, that marginal risk. Remember, when I go back, cellular outlook, it goes all the way up into Montana, all the way down to Texas, right? And back towards Arkansas, right? Parts of Missouri. So you can understand, looking at those instability levels, why that's like that, right? So going back to the model, HRRR. Another thing we look at is 0 to 3 kilometer cape. And what is that? That's the convective available potential energy at the lowest 3 kilometers. And if it's even like 50 to 100, or even a little bit less than that, I have a chart here that I use for reference. See, it has all different parameters in it, and it helps me remember what's required, right? So when I look at 0 to 3 kilometer cape, less than 30, you have a slight threat for severe weather. It says it right on here, okay? I mean, I know you can't see that, but you see it there. 0 kilometer cape. So it's a pretty good cheat sheet, right? Because it's hard to remember all this stuff. 30 to 80 joules per kilogram is moderate, and greater than 80 joules per kilogram is high. Now, that's, you have to have other things in that parameter space as well. See different columns there. So those are all the parameters that you look at when it comes to severe weather. So I think I'm going to take this up right here for my reference, right? It makes it easier, right? I should have done that a long time ago. So in our area of interest, 0 to 3 kilometer cape, okay? Now, let's bring this through. See in the Kansas City area, that system is moving through this morning, right? And see our best 3 kilometer cape values, 0 to 3 kilometer cape values are in parts of Kansas and points eastward here, Sioux Falls, all the way up to Montana. And the southernmost of this, not a lot of low-level cape, right? This is 5 p.m. You can see where it's maximized up here in the parts of just to the north. Dang it, these states. I wish these are labeled. I don't know why they're not. Maybe that's a bug, but maybe I have to talk to him about that. Hi. This is maddening sometimes looking at this. When I can't remember the state, sometimes I just blows my mind. I can't remember these. But anyway, you see where the highest 0 to 3 kilometer cape values are. Another thing we look at is sin, which is like the inhibiting factors, right? Let's start off the day. I have quite a bit of sin here. It erodes as we go through time in the afternoon and evening hours, and almost to nothing here down to in the favorite area where we got the severe weather threat. Okay, so sin is an inhibiting factor, just a measure of that's on this chart as well. So greater than 60 of a slight threat, 60 to 30 moderate, high threat, wait, yeah, high threat less than 30. So that's a general rule of thumb, although you can't write a book about it. All right, so plenty, the sin is eroded according to this model. You see further to the south, it's a lot higher here, so it's going to be harder for convection to fire. All right, so helicity values, storm relative helicity is an important factor as well. 0 to 1 kilometer and 0 to 3 kilometer values will help us look at severe weather potential, right? This is 0 to 1 kilometer. See, the greatest helicity values are in the afternoon and evening hours here when storms start firing up, right? And just the general areas here of different enhanced values. All right, it's here 400 meters squared per second square. There's more than sufficient for severe weather. And here's your 0 to 3 kilometer. This is pretty impressive right here. So start off your day, and then you get into the evening hours. See these values approaching, wow, that's pretty incredible right here. I wish it was labeled, but 600, 700, 900 here. That's pretty incredible. But anyway, you can see why the severe threat is enhanced right there. And it moves to the north. All right, so shear, 0 to 1 kilometer shear. Go through the afternoon hours, increases once again here. This looks like a surface flow here. I mean, two different, maybe three different like surface flow circulations, maybe back here in the Denver area as well. So kind of interesting features here as well. Then you look at 0.6 kilometer shear, still quite good here, 30, 40, 50 knots, 60 knots, anywhere in these areas. So more than sufficient for severe weather. All right. Significant tornado parameter. All right. Within this area, 11 a.m., 5, 6, 7, 8. See, it's maximized further to the north here into Nebraska. Okay. So maybe the chance for significant tornadoes is maximized up here. Now let's look at the severe weather outlook and go to the tornado outlook. Yeah, so you see why you have your, well, one of the reasons why your most coverage is expected in this area, right? That's where your significant tornado parameter values are highest. Back to the model. All right. Maximized in the evening hours, overnight, right? Start the day, not too much. Not that impressive, but now we look at supercell composite. The CP values, plenty of enhancement of the supercell composite. It's just a bunch of different values put together to depict the possibility for supercells. So you see where it's maximized, even up to Montana, but the highest values are in the Kansas and Nebraska here, and maybe into Missouri as well. All right. And even in the southern Texas and northeastern Texas as well. Here's your energy helicity index. When it reaches these values, that's pretty impressive as well, right? And you can see it kind of gives you an idea of the energy in the atmosphere. 0.3 kilometer, very impressive here. Any value greater than 3 is a high threat here. So plenty of energy in the atmosphere as well. So that being said, what is the timing based on this model of convection firing? Let's take a look. Moving on to the severe weather, reflectivity. All right, so we know our area of interest is HRRR starting off about now. Looks relatively clear until 4 or 5 p.m. Some convection firing down here in parts of Oklahoma, parts of Kansas here, and up into parts of Montana as well. Some overall convection up here. Maybe some convection firing down here in southern Texas. If these can remain discrete, then that will be more of a threat, but it looks like it congeals pretty quickly. But you see this dark area here, that's where the updraft helicity is greater than 75 meters squared per second square. So that's a parameter you see on a lot of different models that gives the indication of some rotating storms there, okay? Just to the northwest of North Platte, some other clusters of storms down towards Wichita Falls, Oklahoma City, and just to the north of San Antonio, and just a lot of convection firing up here in Montana, even into the North Dakota, South Dakota, and Minnesota. But it looks like, based on this model, this is showing the most convection up here between like 5, 6, 7, moving to the north and east, and maybe some rotating storms within this line here as it moves towards Omaha, Nebraska, and Kansas City. Another line here with some pretty strong cells as well, gusty winds. The convection seems to wane some as it moves towards Oklahoma City, right? 12 a.m. You see this whole line is kind of congealing here, move to the north, right? And likely will shear out when it loses some of the properties that drive severe weather, right? Instability and different wind values, right? So overnight, typically your convection wanes too because you lose that instability of the atmosphere, all right? Still heavy rain, gusty winds on the northern side of this, and this line is kind of just hanging out down here in Oklahoma. You're talking 5 a.m. now, and that's about it. So let's go to the NAM Nest, see what it says about this. So we're starting today about 6 p.m. It's a little more bullish on these rotating storms anywhere in this general line, right? And up to Rapid City as well, up into Montana also. All right. But generally the convection starts firing about the same time, okay? So, but really congeals into a line pretty quickly and moves to the north. So now, excuse me, I like to use StormNet. It really is good at showing where the greatest probability for tornadoes, excuse me, hail and winds are, right? So this is just probabilities, right? And timing. So going through the evening hours, this is your tornado risk, okay? It looks to might be maximized starting about 4 to 5 p.m. up here in southwestern Nebraska into Kansas, all right? And parts of northern Oklahoma. The highest probability is right centered here in southwest Nebraska, northwest Kansas, northeast Colorado, okay? Although smaller probabilities that around it, right? You see it moves to the north and east here, 9, 10, with another bullseye here just south of Lincoln, Nebraska. The greatest threat looks to be centered here, Stapleton, okay? So that threat moves to the north and east, and you see it wanes over time into the morning hours. So going back to hail risk, all right? You can see already where the greatest hail risk is. So you start off your day, 2, 3, 4, 5 p.m. Hail risk just to the east of Denver Metro, Cheyenne, Fort Collins here, just on the east of that. But the greatest risk is here just to the north of Dodge City, really ramping up into the evening hours as that line moves to the north and east that we showed in the other analysis here. And another area up here in South Dakota. This is 9, 10 p.m. And then hail risk goes through Kansas and Missouri and wanes over time. Wind risk, greater than 50 mile per hour wind risk. Okay, that's what that's showing. 2, 3, 4, 5 p.m. Greatest wind risk, bullseye here, almost a 50% chance of those gusty winds in this area, just in southwest Nebraska, parts of northern Kansas, down into parts of Oklahoma, Texas, Oklahoma border, 8, 9 p.m., parts of South Dakota and Montana as well. Highest probabilities in the green here, right? So that moves to the north and east, and we get the morning hours, and that's it with that. So that wraps it up for my severe weather forecast for today. I hope you all got something out of this. I appreciate y'all. Have a good day. God bless. And be safe out there.